Hi students, welcome back to the online classes. This is the third session of the lesson Laws of Motion. So in the previous sessions we have discussed about Newton's first law of motion and Newton's second law of motion. Now we will discuss about Newton's third law of motion. Newton's third law of motion. To understand about this, let us discuss an activity. So, for this activity, consider two spring balances. Consider two spring balances and attach as shown like here. So, attach the two springs. So, this spring balance will helps to find how much force was applied. This spring balance because of the extension in the spring. So if you add some weight to the spring balance, the spring will extend, the spring will expand, the spring will expand and denotes how much force is applied by this block. So if you add a mass, if you attach a mass to the spring will undergoes an extension. An expansion will be applied by the weight, by the gravitational force. So the applied force, this weight is nothing but force. That force will be obtained by the readings on this spring balance. So in this way, this spring balance will give how much force was applied, or otherwise if it will give in kgs. If it denotes 9 kgs into 9.8 will give the force value, in newtons. Okay, so in this way, if it denotes in the 9 kgs, if it denotes in this format or in the format of newtons, in both the cases it will be equivalent. It will be approximately considered as equivalent to the force value. So like that, this spring balance will give the value of the forces applied. It will give the force value. So you have considered two spring balances and attached here there will be readings present, a pointer will be there and readings will be present along this spring balance. So a pointer will be there. So one of the spring is rigidly fixed to the wall, to a rigid support. It was rigidly fixed, and at other end apply the force with your hand. So apply the force with your hand. Let us say this is your hand. So you are applying a force and pulling the spring. So the applied force will be denoted here. How much force you have applied that value can you get here? You can get that value from here. So you have applied a 20 newtons of force and this pointer is denoting 20 newtons of force was applied, but this spring is also denotes 20 newtons of force. So here you have applied force only on this spring only, but why the readings are same in this spring also. So here whatever the force you have applied, that applied force is having some reaction force. So this spring will again pull the spring. So this is the action force and reaction force will be in the opposite direction. So in this way, so this is the example where if the force is applied and reaction force will also be seen. For example, this action and reaction force, we will, for example, for every force, what is Newton's third law is, for every force, for every action, there is equal and opposite reaction. For every action there is equal and opposite reaction. So according to Newton's third law of motion, for every action there is equal and opposite reaction. For example, if I strike the board, if I apply some force on this board, I have applied some force on this board, I I have applied some force on this board, and this force will again applies on me in the opposite direction. So that's why I will hurt little bit. So I was injured with the application of this force. Who was applied force on my hand? I was applied initially, and reaction force was applied by the board on me. When I strike this board, when I strike this object, when I strike this particular object, I have applied force on the board and I was get hurted. Who was applied this force? For this action force, a reaction was obtained on my hand. So for every action, whatever the force applied on this object will also apply force on my hand. While you are walking, observe the force applied by your foot on the ground. You will apply force in the backward direction. You will apply force in the backward direction. Then it will pushes you in the forward direction. For the action you have made with your foot on the ground, you have made an action. You have applied some force on the ground in the backward direction. Then it will push us in the forward direction. So while you are walking, let us observe the force applied by your foot on the ground. So you are applying the force in the backward direction. You are pushing the ground, you are applying force in the backward direction, and the reaction force is making you to move in the forward direction. So in this way, for every action there is equal and opposite reaction also. So there are several examples in the nature. For example, the birds in the sky. What will happen? With the wings of the bird will pushes the air in the backward direction. How the bird flies? It will pushes the air in the backward direction. It will apply force on the air in the backward direction. So again the air will pushes the bird in the forward direction. If it applies force in the backward direction, it will move in the forward direction. So this is the action force. What is the action force? Bird applies a force on the air. What is the reaction force? Air applies force on the bird. We will call these forces as action and reaction pair of forces. Action and reaction pairs. Action and reaction pair of forces. Action and reaction pair of forces. So for every action there is equal and opposite reaction. So we have learnt Newton's first law and Newton's second law. What is Newton's first law? Every object likes to stay in the rest or in uniform motion unless a force acts on it. What is Newton's second law? The net force acting on the object is equal to the rate of change of momentum. These two laws is related to single object, but Newton's third law is related to two objects. One is force applied. So bird applied the force on the air and air applies the force on the bird. So here two objects will be there. If you apply force on the ground with your leg, you have applied force on the ground, and again the ground will apply the force on you. That's why you will move in the forward direction. So in this way, this Newton's third law is related to two bodies, related to two objects. So let us say any other example. If the fishes in the water applies force in the backward direction, so that the fishes will move in the forward direction. In the case of rockets, what will happen? From the nozzle, with high velocity gases will expel. The gases will comes out with high velocity. The gases will apply force on the surroundings, the surrounding air. So with this force, this is the applied force, this is the action force, and this air will move because of the force applied on air. So the expel of gases applies a reaction force in the upward direction. So the forces applied by the expelled gases is action force. So because of this action force, the rocket will obtain a reaction force and moves in the upward direction. So the rockets will work because of the principle of working on the Newton's third law of motion. The rockets will work with the Newton's third law of motion. So let us explain. Let us discuss another activity that describes about the Newton's third law of motion. So you can perform this activity at your home. It is very easy. So all the things will be available for you also. Let us consider a balloon. Let us consider a balloon and a straw. So blow the balloon. Blow the balloon. This is the mouth of the balloon. So blow the balloon and stick a straw to this. Stick a straw to this. I have stick a straw to this. So hold the mouth of the balloon so that the gases will not escape from that balloon. So insert a thread through this straw. Insert a thread through this straw. Insert a thread through this straw and hold one end of the thread. Hold one end of the thread and tie this one end of the thread at a long distance. At a long distance. Now, if you release the balloon, what will happen? The gases will escape with high velocity through the mouth. Through the mouth, the gases will escape. So, because of the applied force on the air, the balloon will move in the forward direction. This is the action force. This is the reaction force. The balloon will move along the thread. Why? Because you have created a path with the help of straw. Otherwise, it will move in the irregular direction. So, by attaching a straw to the thread, it will move only along the thread only. It will move only along the thread. So, this is the action force and this is the reaction force. So, because of the gases, what is the action force here? The gases coming out of the balloon exert force on the air. Will apply force on the air, and this air exerts force, reaction force in the forward direction. So this is the force applied by the gases on the air, and this is the force applied by the air on the balloon. So that force will helps to move the balloon in the forward direction. So here in the Newton's third law of motion is related to two objects, and the two forces, action and reaction pairs of forces, are equal and opposite direction. For example, let us consider, to get a mathematical form, I will explain how the mathematical equation will be obtained. So this is object A, this is object B, object A and object B. So the object B is applied some force on A. So this is the force applied on A by the object B, and the reaction force will be applied by A on object B. This is FBA, force applied on B on A. So this is the equation form. FAB is equal to minus FBA. If A applies force on, so FA is the force applied on A, B by the B, then A will also apply force on B. So if A is exerted by the force by B, a force is applied on A by the object B, then the A object will also apply force on object B. So these two forces are equal. These two forces are equal and opposite direction. So to indicate the direction, I have placed a negative sign. What is FAB? FAB is the force exerted on A, force exerted on A by object B, by object B. What is FBA? If B applies force on object A, then A will also apply equal and opposite force on the object B. So this is the force force exerted on B by object A, So this is the equation format for the Newton's third law of motion. This is the equation format for the Newton's third law of motion. So after stating the Newton's third law of motion, you have to write FAB is equal to F minus FBA. What is FAB? Force exerted on A by the object B. Force applied on A by the object B. What is the reaction? Force applied on B by the object A. So I have applied a force on the board, on this object. I have applied a force on this object. Force applied by the object A on board. This is object A, this is B. I have applied force on B. This is A, force applied on B by the A. Again, this B will apply force on A. So these two are, this is in this direction and another force is in this direction. So this is the Newton's third law of motion. So let us discuss about conservation of momentum. Let us discuss about conservation of momentum. It is the result obtained from the Newton's third law of motion. Let us learn about conservation of momentum. Conservation of momentum. Conservation means constant. Momentum is constant. I will explain this conservation of momentum now, and later I will explain clearly what is conservation after the result that we will get. So to study about the conservation of momentum, let us consider two objects. This is mass m1. This is another object, mass m2. Let us say these are the marbles. So this is marble of mass m1. This is another marble of mass m2. And initially the velocity of this mass is u1, and the velocity of mass this is u2. The initial velocity of mass m1 is marble 1 is u1, and initial velocity of mass 2 is u2. These are the two marbles. So after these marbles are struck here, means they are collided. After collision, they will not travel with the same velocities. The velocities may be different. So now the final velocity is v1, and the final velocity is of second marble is v2. The second marble is v2. I have considered a system. How many objects are there in the system? I was analyzing the two objects. So initially m1 and m2, their velocities are u1 and u2 respectively. After collision, so a collision was occurred, and after collision, is they travel with same velocity? No, they will travel with different velocities. What are those velocities? v1 and v2. So here for marble 1, marble 2. So initial momentum means before collision. What is momentum? Momentum P is equal to mass into velocity. For marble 1, before collision, what is the momentum? m1 into u1. For second marble, what is the velocity? u2. So hence initial momentum is equal to m2 u2. Initial momentum is equal to m2 u2. After collision, after final momentum, What is the final momentum? m1 v1. Momentum is the mass into v. So after collision, final momentum is after collision the momentum becomes m1 v1. m1 v1. And what is the momentum here? m2 v2. m2 v2 is the final momentum. Final momentum means after collision the momentum of marble 2 is m2 into v2. So let us find out the change in momentum. So here the change in momentum of the first object, delta p1. Delta p1 is the change, m1 v1 minus m1 u1, final minus initial. So delta p2, m2 v2 minus m2 u2. So this is the change in the momentum. Change is denoted with delta. Change will be denoted with delta. P is the momentum, delta p is the change in momentum. I have calculated the change in momentum. What was the change? m1 v1 minus m1 u1. What was the change in momentum of this marble 2? m2 v2 minus m2 u2. So at the time of collision, how much time was taken? The collision time is t seconds. The collision was occurred for t seconds. This may not be large one. Maybe the collision was occurred for 0.001 second. How much time the collision was occurred? In the time of 0.01 second. The collision was occurred. The two objects are in contact during the time for the time interval 0.01 seconds. The collision was occurred in that time. So here two objects is there. During collisions, the first object will apply force on second object and reaction force will be applied on first object by the second one. So here according to Newton's second law, F12 is equal to minus F21. Initially I have explained in the terms of A and B, but I was represented here 1 and 2. F12, force applied on first object due to the second one. And what is this? F21, force applied on second object by the first object, that is the reaction force. This is equal and opposite direction. So according to Newton's second law, force F is equal to delta P by delta T. Force F is equal to delta P by delta T. So this is the force applied on first object. This is the force applied on second object. So since this is the force applied on first object, we have to consider change in momentum of the first object by time taken is equal to minus, this is the force applied on second object. So you have to consider change in momentum of the second object by delta t. So here delta t cancel. What is the change in momentum of first object? m1 v1 minus m1 u1 is equal to minus into, what is the change in the momentum of the second object? m2 v2 minus m2 u2. So multiply that minus, m1 v1 minus m1 u1 is equal to minus into plus minus m2 v2 minus into minus plus m2 v2. So bring this minus m2 v2 to this side and bring this minus m1 u1 to that side. So m1 v1, if you bring this minus term to this side, it will become plus m2 v2 is equal to, bring this minus m1 u1 to that side, m1 u1 plus m2 u2. So just rewrite the equation, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So this equation describes about conservation of momentum. This equation describes about conservation of momentum. What is this equation? Momentum of the first object, initial momentum of the first object, m1 u1, m2 u2, initial momentum of the second object. What is the total momentum of the system? m1 u1 plus m2 u2. This is the initial momentum of the first object. This is the initial momentum of the second object. The total momentum is m1u1 plus m2u2. What is the final momentum, total momentum? m1v1 plus m2v2. Here the first initial momentum is equal to the final momentum. The total momentum of the system doesn't changes. Initial momentum of the system, I am not talking about the momentum of the object, total momentum of the system. The total momentum of the system is equal to the final momentum. Initial momentum of the system is equal to the final momentum. Here momentum is conserved, momentum is constant. There is no change in the momentum of the system. There is no change. Here m1u1 plus m2u2 is equal to m1v1 plus m2v2. So this is the result obtained. So whenever Newton's third law is valuable, whenever there are external forces acting on the object are zero, forces are acting internally. So this is the system. Our system consists of two objects. So the forces are acting in between the objects, but no other external forces are there. So in this case, the initial momentum of the system is equal to the final momentum. Momentum is conserved. Momentum doesn't loses. So here, so this result, conservation of momentum result, is the consequence that was obtained by the Newton's third law of motion. Consequence means result. Consequence means result. If the forces acting on the system is zero, here no more forces acting, external forces are not there, internally are there. During the collision, internally forces are acting in between 1 and 2. These two objects together we will call as system. So on the system there are no more external forces, only the force is between the two objects. So when forces acting on the system is zero, the momentum of the system is constant. The momentum of the system is constant. The initial momentum m1u1 plus m2u2 is equal to m1v1 plus m2v2. So this is about conservation of momentum. So conservation of momentum is the consequence of Newton's third law. Consequence means the result obtained by the Newton's third law of motion. Because of this Newton's third law, momentum was conserved. That is the meaning of consequence. So let us discuss about impulse. So according to Newton's second law of motion, the net force acting on the object is given by, what is the equation format of Newton's second law of motion? The equation format is F net is equal to delta P by delta T. F net is equal to delta P by delta T. So bring this delta T to this side, then delta P is equal to F net into delta T. F net into delta T. Here delta P is the change in momentum. Delta P is the change in momentum. Delta indicates change. So we will call this change in momentum as impulse. Impulse is denoted with capital J. It is nothing but change in momentum F net into delta T. For example, when you jump on a concrete floor from certain height, when you jump on a concrete floor, will hurts you a lot, it will impact you a lot. Here the greater force will be applied. For suppose if you jump on a soft cushion, there is some cushion arranged for you, and if you jump on that cushion, what will happen? Here it will not impact you a lot. When you jump on a sand, it will not impact you a lot. Why? Because here time of contact will be less. So what is force? F is equal to delta P by delta T. When the time of contact is less, the force will be greater. Why? Because it is inversely proportional. It is in the denominator and it is in the numerator. So we will call this as inversely proportional relation. When the time of contact is less, the force will be greater. When the time of contact is greater, the force will be less. Whenever you are catching the cricket ball, you will drag that ball in the backward direction. Why? Because you are increasing the time of contact. You are increasing the time of contact. So if you increase this delta t value, you will experience a less force. If you catch the object abruptly, suddenly if you catch that object, it will impact you a lot. It will affect you a lot. So why? Because if you didn't drag your hand in the backward direction, the time of contact is very less. To stop that object, the time of contact is very less, then you will be experience a greater force. So because of this, of course the change in momentum is same. While stopping the ball suddenly or with a drag of motion, the change of momentum was same, but the impulsive forces are different. Impulsive forces are different. We will call these forces as impulsive force. Okay. So if you increase the time of contact, you will experience a less force. If you decrease the time of contact, it will affect you a lot. So on the concrete floor, the time of contact will be less. To make the momentum zero, the time of contact is zero. The cushion will increase the time to make the momentum zero. That's why you will experience a less force. So with this chapter laws of motion is completed. Thank you.